Okay, so now we're just going to practice with some separable equations or separable stuff, ODEs, thingies. Anyway, example, try this one. A lot of these are going to be initial value problems. Okay, so like give this one a shot. So remember the whole idea with separable equations is that you move all of the y's to one side and you move all the x's to the other side and you just solve and see what happens. Okay, so as you're looking at this, pause the video, see how far you get. All right, so we'll assume that happened. I don't know how many examples we're going to do, just in case you're wondering. Probably like, I don't know, 3 or 4 or something like that, maybe 4. I don't know, but anyway, remember the first step is to get all the y's on one side. So I have dy or y dy is equal to negative x dx. Okay, I'm going to integrate both sides. Integrate. On the left, I've got 1/2 y squared. And on the right, I've got negative 1/2 x squared plus c. Now I know that y at 1 is equal to 1, so it's equal to 1 whenever x is equal to 1. So that means that 1/2 equals negative 1/2 plus c, so c is equal to 1. Yay! No, wait. Yeah, c is equal to 1. Good. Okay, I can do this. Okay, so I can come in here and I can say that 1/2 y squared is equal to negative 1/2 x squared plus 1. Well, that's kind of goofy, so I'm just going to multiply the whole thing by 2. And I'll have that y squared plus x squared is equal to 2. Now, I can actually leave the form like this. This is called an implicit solution. It's called an implicit solution basically because I don't have an actual y equals thingy, but like the value of y is implied. Because if I really wanted, I could come up with this like that and get an explicit solution. So if you're ever doing a problem and it asks you for an implicit solution, just know that that means that it's okay to leave it in terms of the equation of a circle. Or however you want to do it, just doesn't have to be explicitly in terms of y. Kind of makes sense? Okay, got it. All right, let's try another one. All right, so try this guy. Do y prime is equal to 2x plus 1 over 5y to the 4th plus 1. Again, some little lowball just to get you started. And I'll make it an initial value problem to give you initial condition of y at 2 is equal to 1. Okay, so again, I'll give you 2 more after this. For sure, 2 more. So pause the video. The last one's going to be really good. You wanna do it. So. Oh, wait, never mind. We'll give you a whole lot more. I found some more problems. This is going to be great. You're going to love it. Okay, so definitely hang in there if you're thinking these are a little bit easy. Just do them right quick to make sure you got them. If they're that easy, you should be able to do it by now. So let's pretend that instead of listening to me talking, you're actually doing the problem. So I've got 5y to the 4th plus 1, all that thing dy is equal to 2x plus 1, all that thing dx. If you're getting lost here, it's probably because you're having problems with the calculus. If you're having problems with the calculus, unfortunately, Diffie-Q is not going to be the right thing for you to do right now. Best thing you can do is go retake Cal 2, come back to this class and be like, man, I got this. Okay, so I integrated that on the left, I got that. I integrate this on the right, I get x squared plus x plus c. Wahoo! So if I go y at 2, I'm going to apply that initial condition y at 2. Thank you. I'm really excited that Windows Explorer stopped working. Y at 2 is equal to 1. So 1 to the 5th plus 1 is equal to at 2. The at 2 part is 2 squared plus 2 plus c. So I've got 2 is equal to 4 plus 2 is equal to c. So c is, plus c. So c better be equal to negative 4. So I have y to the 5th plus y is equal to x squared plus x minus 4. And that's the solution to that differential equation. Okay, kind of getting it? Kind of getting the feel? Yay! All right, just a couple more just to help you warm up. And remember, we're not trying to go crazy on these problems. We're really trying to build your confidence so I can dash it toward the end of the video because that's the joy of teaching. Like that. No initial condition here, just solve it. Again, pause the video, see how far you can get. And assuming that's happened, here we go. I'm going to make this y to the negative 2 dy, just because it's going to be easier for me to integrate later. Dx. Integrate both sides. Integrate. And on the left, if I integrate that, you remember that goes up. So it doesn't go down to negative 3. It goes up to negative 1. So negative y to the negative 1. If you don't believe me, differentiate this. Take the negative 1 down, becomes a positive. Subtract 1, you got a minus 2. equals x squared plus c. So basically negative 1 over y is equal to x squared plus c. Beautiful. Again, this is called an this is called an implicit solution because we don't have something exactly in terms of y, we have something in terms of negative 1 over y, and that's okay too. Alright, now I'm going to give you this one, and don't get too cocky because you might run into some problems. This is where the confidence gets shattered. This is why I got into teaching in the first place. That's not true. I got into teaching because it's super fun and I get to do math all day. Alright, so pause the video, see how far you can get on this. If you need a hint, if you don't need a hint, hit pause, pause, pause. If you need a hint, you're going to need partial fractions. Partial fractions. Okay, hoping you pause the video. 1 minus y squared dy is equal to 1/2 x. Maybe you solved it without partial fractions. Who knows? Alright. So on the left, we had something like this on the left somewhere else, but it looked like this. And it was a plus, and we knew that that was inverse tangent, or we figured out that it was inverse tangent eventually. In a case like this, that's not inverse tangent, but anytime you're integrating, and you probably remember this, anytime you're integrating over something where you can factor out the bottom, that's when you want to use partial fractions, okay? So if you can factor out the bottom, generally you're going to be wanting to use partial fractions. So partial fractions basically means that I recognize that on the left I can factor this to 1 minus y times 1 plus y. So the whole idea is I go, well, I recognize that I can rewrite this as 1 minus y and then 1 plus y. Now there's all kinds of videos on reviewing partial fractions out there. I think I've got a couple as well. So you can mess around with that if this is giving you trouble, but I'm just going to run through this right quick. So I'm going to multiply the whole thing times 1 plus y and 1 minus y. And the reason, of course, that when I do that I end up with a times 1 plus y plus b times 1 minus y. And there's a trick to finding a and b. If I want, I can let y equal negative 1. Because if I let y equal negative 1, I get a 0 here, right, because the negative 1. And then I get a 2 here, so that means that b equals 1/2. And then if I let y equal positive 1, then I get 1 plus 2a plus b times 0. 1 equals. And again, a is equal to 1/2. That's just a coincidence. That doesn't usually happen, so don't get excited and be like, if I solve for 1, it'll always be the same as the other one. So basically what it means is I can replace this here. I can replace this here with, so I had this. I can replace it with 1/2, 1 minus y, plus 1/2, 1 plus y. And I care because this is a lot easier to integrate. This here is easier to integrate than the other one. So I'm going to come over here. On the left, I'll have 1/2 times the integral of 1 minus y plus 1/2 times the integral of 1 plus y because of partial fraction decomposition. That's going to equal, and I'm just kind of getting tiny because apparently I feel the need to fit everything in one teeny weeny spot. Ooh, I can move this over because I'm amazing. Okay, and then so here on the right, I've got blanking x 1/4 x squared. Yes, okay. Woo! Sorry for a minute there, that was kind of scary. Alright. Alright. I'm going to go ahead and multiply this whole thing by 2 because there's absolutely no reason for all those ridiculous fractions. So I'm going to integrate 1 over 1 minus y dy. dy, silly girl. Plus integral of 1 plus y dy. And that's equal to 1/2 x squared, still plus c, because who cares if it's c or half of c? Till I actually solve for c, it doesn't actually matter. Alright, so on the left, depending on how good you are at integration, you maybe theoretically could look at that and realize that that's negative natural log of 1 minus y. I've actually worked it out in an earlier video, but if you take the differentiation of that, if you chain rule it, you've got 1 over 1 minus y, and then you chain rule the inside, so you got an extra negative sign out front, so that should take care of that. And the integral of the second one is just natural log of 1 plus y. So on the right, I've still got this thing. Now, do you remember how to simplify the stuff on the left? Because you still want to simplify it, even if we're just looking for an implicit solution, it's still nice to have it pretty. Remember whenever you're subtracting natural logs, that the things that you add go on the top, the things that you subtract go on the bottom. And they're inside an absolute value sign because you can't have a logarithm of a negative number. The value of a logarithm can be a negative number, but you can't take the log of a negative number. And you know what? I'm probably going to be totally happy with that solution. Okay? So that knocked you down a peg or two? Maybe? Mayhaps? Maybe not? All right. Well, let's do one final example then. Okay. This one's great because it actually uses variation of parameters and separation of variables. So say we've got y prime plus y is equal to 2x e to the minus x over 1 plus y e to the x. And you're like, oh man, this is not fun. Because this is the first time, before whenever we were doing variation of parameters, everything on the right was a function of x by itself, and now we actually have a y in there. So we're going to try variation of parameters and separation of variables again and just see if it works. And if it does, we're going to be super excited. If it doesn't, we'll chalk it up. The good news is it's going to work. Okay, so go ahead and pause your video and see if you can work this out. Okay, so assuming that's happened, that means that on the right, we're going to solve the homogeneous portion of this problem. So y homogeneous prime plus y homogeneous is equal to 0. So that means that y homogeneous is equal to e to the negative, 1 dx, which is just e to the negative x plus c. But since we're just folding it into a guess, it's not going to matter. Our guess is going to be that y is equal to u times e to the negative x. So y prime, see, this is when you really want to give up. So if you've given up, you should pause the video and come back later and try it for realsies instead of like being like, oh, that's okay, I'll just pick it up later. Because you got to get used to working when it's hard and not just working when it's easy. And that's my advice for today. So I'm going to plug this in, and I've got u prime e to the negative x minus u e to the negative x, so that's my y prime. Then plug in my y, and then it equals this stuff. Now I have a y again, so I'm going to plug that y in again. U e to the negative x times e to the x, okay? So just to make sure we're cool, this is my y here, here, and here. Or here, and here. There's my y's. I've got two y's. And there's my u prime, or my y prime, sorry, right here. Okay, everything else is x's and u's now. Ooh, my goodness, pop back. Okay. So, luckily, as we would expect, the stuff in the middle cancels out, so that makes me happy. U prime e to the negative x is equal to 2x e to the negative x over 1 plus u. The e to the x's actually cancel out, e to the negative x's cancel out, which is nice. And now I have a beautiful separable equation, 2x dx, which can now be integrated. Woohoo, look at how exciting this is. So I'm going to integrate stuff. It's going to be amazing. So here on the left, yes. On the left, I'm going to get u plus 1/2 u squared. And on the right, I'm going to get x squared plus c. Now, unfortunately, you think, well, I've got to solve for u, which is kind of awful because that's really like kind of like a quadratic equation, like this, plus this, and then there's like this thing here where it's this, like this, and then that's kind of like a differential, or a quadratic equation, and I really want to do this, but that's okay, because actually there's kind of a sneaky way around it. You don't actually have to solve for u independently. Actually, my guess was that y was equal to, I already forgot. What was my guess? My guess was that y was equal to u e to the minus x. So what I can do is, instead of solving for u explicitly, what I can do is I can go in and I can actually solve for u. So I can say that u is equal to y times e to the positive x, right? Because I flip it to the other side. So I've got y e to the x plus 1/2 y e to the x quantity squared is equal to x squared plus c. And so now I have an implicit solution, x, that thingy, this thingy is equal to that thingy. it's nice, and a mother can love that thing, and it's a pretty equation. It makes me happy. So basically, here's something that you can try out. It's just kind of the lazy person's way of getting around solving for you is just to give an implicit instead of an explicit solution. So that's kind of fun. Hope you learned something.